Hey guys, welcome back to Extreme IE. Now, if you're fresh off of the layer 2 switching video and you came here expecting to see what a layer 3 switch is, I'm sorry I lied to you. I know I said that would be the next video, but I realized that there was really no way for me to explain to you what a layer 3 switch does without first explaining what a router does. And I can't explain what a router does without explaining to you a little bit of subnetting and IP addressing. Now, we're not going to get really deep into IP addressing. There's some things here that may not make complete sense, and that's okay because there'll be a later video where I show you exactly how to subnet and I show you how to understand what an IP address is. But for the sake of this video, we're just going to kind of graze over it. We're just going to take a few, licks of the icing here, and this way you'll understand what a router does. So an IP address, every device on your network is going to have its own unique, or it should have its own unique IP address. Just like every device has its own layer 2 hardware address, meaning that MAC address that's attached to the physical network card of your device, you should have an individual IP address that's assigned to your device when you come onto the network. When you have two devices with the same IP address, things can get a little funky, but in this case, we're just going to assume that everything has its own individual IP address, which is, again, is how it should work. Now, an IP address is going to be made up of 4 what we call octets. So let's take an IP address that maybe you have at home. So maybe your home network is 192.168.1.0. These are 4 different octets. So you have 1, 2, 3, 4. Between each period is what we call an octet. Each octet is 8 bits long. And now I'm not going to go deeper into that, just bear with me. So each octet is 8 bits. So there's 8 bits we can turn on here. There's 8 bits we can turn on here. There's 8 bits we can turn on here. And there's 8 bits we can turn on here. An IP address is a 32-bit long address. So when you think about bits, at the end of the day, an IP address is just a bunch of ones and zeros, and depending on the combination of ones and zeros that you turn on, essentially dictates what number that is in the IP address. So an IP address is 32 bits long. Now, you may notice something interesting here if you've ever looked at subnetting, or if you've ever even, if you've ever written down an IP address and you've given somebody what we call a CIDR. Again, I'll get into some of this stuff in a later subnetting video, but you need to understand this to understand what a router is. You may notice that these also correspond to a CIDR. So you might see somebody write this address as follows: 192.168.1.0/24. What essentially this is saying is that at the end of the 24th bit, that is where the client addresses begin and the network portion of the address ends. So this /24 is saying everything up to the 24th bit belongs to the network. So this is going to assign or dictate what network we are on. And everything up to the 32-bit, in other words, between 24 and 32, these are going to be for our clients. So you may have a printer that is 192.168.1.10, and you may have a desktop that's 192.168.1.12, and so on and so on and so on. These addresses will never change. It will always be 192.168.1 because that is the network portion of the address. And the client portion, these can be more dynamic. This is where DHCP comes in and it automatically assigns you an address when you come on the network. And this may always be different because these are the client portions of the address. Okay? Now, let's go back to our layer 2 video here for a second. And let's just say that we have a layer 2 switch. I'm just going to put L2 over here. And I remember for our video, we had a desktop connected, we had a laptop connected, and let's just say we had a printer connected. So we'll just say PRNT for printer for short. Now, if all of these devices are on the same subnet, meaning all of these devices are 192.168.1. Whatever, a layer 2 switch is going to function just fine because what's going to happen is it's going to be able to look up the address in that MAC address table. It's going to be able to send the traffic to the right port. The problem is that most of the time this isn't how things work in a large enterprise network or even a small area network, where generally what we're going to do is we are going to put printers in one what we would call VLAN, or virtual local area LAN, or subnet. We can use these terms typically interchangeably, even though they're different. When somebody says VLAN or subnet, they mean the same thing, even though, again, technically they're different, but we'll get there. So what we're going to do is we're going to say, okay, our printers might be 192.168.1.0/24, meaning that from 1, so 192.168.1, that's never going to change, and then the printers are going to have, .10, .12, whatever. Laptops, they might be 192.168.10.0, meaning 192.168.10, that's going to be the network, and then .0. That's going to be the client portion where they can have .1, .12, whatever. And maybe this is going to be 192.168. I don't know, 15, right? We're making this up as we go, but I'm just doing this so that you get the idea. The problem with a layer 2 switch, while it allows for a lot of port density, and while it allows us to plug in, 48 things, and modular switches we can plug in, 200 things, it doesn't route. It doesn't know how to send and receive traffic from different subnets. It does not know how to take IP-based traffic at layer 3, because anytime we change subnets, anytime we have to go in between network addresses, that happens at layer 3 in the OSI model because it's IP-based. A layer 2 switch, by nature operating at layer 2, does not know how to send or receive this traffic, and so essentially everything just dies here. So typically what needs to happen is we need to have a router hanging off of this switch somewhere that has an IP address in each one of the different networks that we have. So you may have a router with an interface of 192, 168, etc., and it's going to have a .1 interface. It's going to have a .10 interface. It's going to have a .15 interface. Now, they don't have to be physical interfaces. So if you're looking at the router here, you'll notice that, first of all, routers look very, very different than switches. They have much smaller port density. They don't have 48 ports. Some of them have more ports than other routers, but generally you're not going to find a 48 port router. So you can have a virtual port. So what I mean by that, and again, we'll do all of this stuff in labs as we get further in the course. You can take this single port and you can say, look, I want you, that one port that's plugged into my layer 2 switch, I want you to answer for traffic that's on multiple subnets. So you can virtualize each interface if you want to from that one physical interface. Other times customers, if you have 4 physical interfaces, as you see this router have, they may have 4 physical interfaces plugged into a switch, and each physical interface has a different address. So what a router essentially does is it allows you to route, it allows you to send traffic between different subnets. And there are different kinds of routers. Generally, this would be what we call a distribution router, meaning it sits somewhere inside of our network and it allows us to send and receive traffic from different subnets. There's also what we would call an edge router. An edge router is something that would essentially connect us out to the internet. Now, in some networks, in some organizations, the edge router and the distribution router are the same router. So you may have a bunch of switches that are connected in your network, and they all connect up to a router just like this, but that same router is connected out to the internet. And so in that case, it's a combined router. It's doing dual purpose, right? It's not only your edge router, but your distribution router. And so again, there are different routing purposes. There's also what we call a core router. A core router is generally used by internet service providers. This is a very, very large, big router. It's meant for large bandwidth. It's meant for, gigabytes and gigabytes of data being transferred through it. There are some very large organizations that have their own core routers that are very, very large, and they're meant to send just tons and tons of data. So again, large enterprises have core routers as well. My point is that the router is essentially the brains of your network. The router is what allows you to send and receive data between different switched networks. So, you're going to have your printer network. You're going to have your laptop network. You're going to have your maybe your IP camera network, right? You're going to have your IP phone network, maybe for your phone system. You're going to have all these different networks, all these different subnets in your environment. And without that router, without that layer 3 device in your network, you won't be able to send traffic between them. The router is what makes that possible. So I hope you guys enjoyed this video. I will see you guys in the next one.